Alrighty, to start Unit 3, we're going to be looking at finding the derivative of trig functions. So, if we were to look at a couple basic definitions here to start with, the derivative of the sine function is cosine, and the derivative of the cosine function is negative sine. Of course, you have to have these all memorized. So from there, if we were to look at tangent, cosecant, cotangent, and secant, you could actually derive these derivatives by using your quotient rule. So if you were to look at tangent, it's sine over cosine. If you did your quotient rule on that and then used your knowledge of identities, you would see that the derivative of the tangent is secant squared. Likewise for cosecant, if you turn that into 1 over sine, the derivative ends up being negative cosecant times the cotangent. For y equals cotangent of x, which can be rewritten as cosine over sine. Again, if you went through your quotient rule and simplified, you'd see your derivative was negative cosecant squared of x. And finally, for y equals the secant of x, which is 1 over cosine, the derivative there is secant of x times tangent of x. Okay? So these are all summarized in this table below. These are 6 trig derivatives that you again have to memorize. Alright. So what you're going to see is that these trig derivatives will show up in lots of different questions where we have to use our rules from before, such as the product rule, quotient rule, chain rule. So we're going to go through a couple quick examples here, and then in class we will build upon this and look at more complicated ones. So here our focus is just going to be on the sine function, whose derivative we know is cosine, and we're going to look at some of the rules that we saw from before. So our first one here, if we have that number in front of 2, that just comes along for the ride. Final answer 2 cosine of x. For our second one here, our derivative would be the cosine of 2x. Now 2x is my inner function, so I would have to chain along a 2. So my final answer will express as 2 cosine of 2x. For the next one here, it's kind of a combination of a and b. My derivative would be same thing, 2, and then cosine of 2x with a 2 chained along, because again the derivative of the inside there would be 2. So that'll give us 4 cosine of 2x. Now with d, if you see sine squared, understand this is the same as the quantity sine of x squared. So now if I go to my derivative, I could use my chain rule. I could multiply that 2 down in front, and then we have times the sine of x to the first, and now we're chaining along the derivative of the inside. Well, the inside is sine of x, so its derivative is cosine of x. So you could write this as 2 sine of x cosine of x, since the power of sine is just 1 there. All right. Next one down below here. So understand that if we were to rewrite this, notice I'm writing y equals, not y prime yet. This is the same as the sine of 2x, whole thing squared. So now I'm ready for y prime. And again, this is chain rule, so 2 times the cosine of 2x. That is my inside. Okay, so the inside is, oops, I'm sorry, that's not correct. Let me go back here. Alright, so we multiply that 2 down, and then we have the sine of 2x on the inside that comes along for the ride. And now we chain along its derivative, which would be the cosine of 2x times 2. So if I were to say to you, find the derivative of just the sine of 2x, which we did up here in part B, we knew the answer was 2 cosine of 2x, right? So when we clean this up, we have 4 sine of 2x cosine of 2x. Okay? So this is tricky because the inner function is the sine of 2x. You're chaining along its derivative. So again, go back to problem B where we found the derivative of the sine of 2x. Okay? For f, I'll do this down here where I have a little more room. First of all, I'm writing y equals. This is the same as y equals the sine of x to the 1/2. So only x is raised to the 1/2 power. So I'm not going to multiply that 1/2 down in front. Now when we get to the next problem, you'll see that we will multiply the 1/2 down in front, because in this next problem, this is the same as the quantity sine. Let me do this down below where I have a little more room. So this is the same as y equals the quantity sine of x to the 1/2. So in this next example, we'll multiply that 1/2 down. But back to this one, the derivative here that we're going to take is of just sine. So that's going to be cosine. Now this is my inner function, so I'm going to have the cosine of this inner function with its derivative chained along. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. So this will give me, if I clean this up, we can write this as 1/2. Let me just reverse this for a moment. This would be the cosine of radical x. From there we know we can keep the 1 up top with the cosine of radical x. The 2 is in the bottom. If you want, you can keep that 1 there if it helps you to see this. And then this x to the negative 1/2, we can throw that in the bottom as radical x. So cosine of radical x all over 2 radical x. If it's multiple choice, that's what you're going to see. So you're taking the derivative of the outer function, which is really sine, and you're getting cosine, and you're carrying along the inner function of x to the 1/2, and then you're chaining along the derivative of that x to the 1/2. Next problem up here, we've already talked about how to rewrite it. So because we have this whole quantity to a power, I can multiply that power down in front. We keep the inside as is, and then we chain along its derivative, which would be cosine of x. Okay? A common mistake for people is instead of putting sine of x on the inside, they want to put cosine of x on the inside. So if you were to simplify this, you would have up top cosine of x all over 2 times the square root of sine of x. So if it's multiple choice, that's what you're likely to see. Okay? And our last one here, this is the same as the quantity sine of 2x to the 1/2 power. So that's still equal to y, and now I'm ready for y prime. So I can multiply that 1/2 down in front, since I have an entire quantity raised to a power. I then have a negative 1/2, and I'm going to chain along the derivative of my inside. So just like we talked about earlier, if I asked you to find the derivative of the sine of 2x, you did it up here in part B, that was 2 cosine of 2x. Okay? So 2 cosine of 2x. Well, when we go to simplify this, your 1/2 and your 2 will go to 1. So you're left with cosine of 2x up top, and then the sine of 2x to the negative 1/2. Let's throw it in the bottom with a big square root over all of it. Okay, so again, if it's multiple choice, that's what you're going to see for your final answer. So in class, we'll look at examples with other trig functions, but this is a good start because it shows you how you're using your rules from before, in particular your chain rule.